All right, let's do one more second derivative question, and this one has to do with that circle. So, steps involved. Hey, if I want to find the second derivative, I need to first find the first derivative. And if I'm not mistaken, we've already done this as well. This is on that circle. So dy dx was equal to, I do believe it was negative x over y. Now that negative sign, I've got a choice. I can either tag it with the x, tag it with the y, or just bring it out front and kind of ignore it until the very end of it. Okay, whenever I go to take the derivative of this first derivative, notice I have a quotient, which means that I will need to use the quotient rule on this one. Okay, you could bring that y up to the top with a negative 1 power and then use the product rule if you really wanted to, but I don't. So let's find the derivative of the derivative, shall we? Okay, so I'm going to leave the negative sign up front, kind of ignore it, and take the derivative of the top, which is 1 times the bottom, y, minus the top, x, times the derivative of the bottom, dy dx, all over the denominator squared. All right, are you ready? Okay, so here is that thing that we have to do whenever we have the first derivative embedded inside of the second derivative. We've got to replace it. So let's do that. Let's substitute that back in there. And I'm going to have a negative y. Whoa. The negative is just out front of this fraction. So y minus x times, and then the first derivative was a negative x over y squared. Complex fraction, which I am going to have to fix, and I can fix that by multiplying by the fancy one, y over y, right? And then distribute that y across the top there. Bring down that negative sign. It'll be y squared. These y's, of course, are going to cancel out, but I do need to multiply this negative x times this negative x to make a plus x squared over, and then y squared times y cubed. So here's our second derivative. Okay, I can leave it like that, of course, and it is possible, though, that there is another substitution. Like again, what if this is multiple choice and I take a look at my answer choices? This is not one of them. But instead, what I see is negative 25 over y cubed. Where did that come from? That came from the fact that x squared plus y squared is equal to 25, and that's exactly what I have right up here. Sure, it's switched around, but you know what? Addition's commutative, so you could flip that around, and that should be equal to 25. So I take that out, replace it with 25. There you go. So there is an alternate form of that second derivative.